Assalamu alaikum, my dear students of Alexandria STEM School, grade 11. Our first session in LO8 is about derivatives of trig functions. Objectives of our lesson: by the end of this session, you should be able to define the derivative of sine and cosine functions and differentiate each of the 6 trigonometric functions the same. Our first activity: how to use the definition of the first derivative to find the derivative of f of x equal sine x. This definition is f dash of x equal limit f of x plus h minus f of x over h as h tends to 0. First, let f of x equal sine x and then f of x plus h equal sine x plus h. Our definition: f dash of x is the limit of f of x plus h minus f of x over h as h tends to 0, which implies to limit sine x plus h minus sine x over h as h tends to 0. How to calculate this limit? We should expand sine x plus h, okay, using the sine rule, which is sine the first, cosine the second, plus cosine the first, sine the second. Okay, so sine x plus h equals sine x cosine h plus cosine x sine h. Subtracting sine x and dividing by h, then taking the limit as h tends to 0, we get the limit in the form of the sum of two limits. The first limit is cosine x sine h over h, and the second limit by taking sine x as a common factor from the first and the third second of the previous equation, sine x times cosine h minus 1 over h. Applying our rules, sine h over h, its limit equal 1 as h tends to 0, and cosine h minus 1 over h, its limit as h tends to 0 equal 0. Okay, 0 multiplying by sine x equal 0, and 1 multiplied by cosine x equal cosine x. So the last rule, result is cosine x. d by dx for sine x equal cosine x. Now your rule to find the derivatives of the last 5 trig functions: cosine x, tan x, cosec x, sec x, and cotan x. For tan x, you can put it in the form of sine x over cosine x and differentiate using the quotient rule. For cosec x, put it in the form 1 of sine x and use the quotient rule. For sec x, put it in the form of 1 over cosine x and use the quotient rule. For cotan x, put it in the form of cosine x over sine x and use the quotient rule. This table gives you all the results. The first derivative of sine x equal cosine x, the first derivative of cosine x equal negative sine x, the first derivative of tan x equal sec square x, the first derivative of cotan x equal negative cosec square x, the first derivative of sec x equal sec x tan x, and the first derivative of cosec x equal negative cosec x cotan x. We can also generalize these results using the chain rule. If we have u, a differentiable function with respect to the variable x, then d by dx for sine u equal cosine u multiplied by the derivative of u with respect to x, which is du by dx. And we can generalize this rule for the rest of trig functions as follows. This slide gives us the generalized derivatives for trigonometric functions. d by dx for sine u equal cosine u du by dx, as we said. D by dx for cosine u equal negative sine u du by dx. D by dx for tan u equal 6 square u du by dx. D by dx for cotan u equal negative cosec square u du by dx. D by dx for sec u equal sec u tan u du by dx. D by dx for cosec u equal negative cosec u cotan u dy by dx. Now we are going to solve some examples. The first example, find dy by dx for each of the following. A, y equal 2 sine 3x plus 4. Okay, this function in the form of a constant multiplied by the sine function. Okay, so its first derivative, let u as it is, let 2 as it is, and differentiate sine 3x plus 4. Okay, putting 3x plus 4 equal u, sine u equal cosine u, so the derivative of sine 3x plus 4 equal cosine 3x plus 4 multiplied by du by dx, which is 3. Now we can multiply 3 by 2 equal 6 cosine 3x plus 4. Another example, y equal 3x minus 5 tan x. Also 3 is a constant multiplied by the derivative of sec x, which is sec x tan x. 5 is a constant multiplied by the derivative of tan x, which is sec square x. Okay, now we can take sec x as a common factor, and the remaining 3 tan x minus 5 sec x between the two brackets. C, y equal x power 3 cosec x. As you see, it is a product of two functions, x power 3 and cosec x. So we have to apply the product rule. So dy by dx equal the derivative of the first function x power 3, its derivative is 3x power 2 multiplied by the second function as it is, plus the first function as it is multiplied by the derivative of the second function, the derivative of cosec x equal negative cosec x cotan x. Okay, now we can take a common factor, which is x power 2 and cosec x. X power 2 multiplied by cosec x is a common factor. The remaining is 3 minus cotan x. Now the two slides are homework. Okay, and I'm waiting for your response on my email. And in the last slide you have two references. You can exercise how to differentiate many functions from the first one, and how to use the calculator to find the first derivative using the second link. Okay, and the last, I hope you the best. Mr. Ahmed Eid. Thank you.